मेरे को याद नहीं है। That's really not a single person.
अच्छा इसको परमिशन नहीं है अभी बैठता हूँ Hi, good afternoon, everyone. So, welcome guys to Day4 Session. Let people join me now. So, in this brief session, uh, the morning we have covered particular cardiovascular applications or cardiovascular culture applications using some of the simple tools. So, just to explain the same in the software, let me open the tool. Yeah, so once the software is open, the task for taking the dataset is same. We need to go the icon images option. Here we need to select a particular folder. So in this session, I shall be discussing less about the tool and more about the case application. And I'll be covering out how we are using this tool for this case studies to do any sort of research. So taking an example for this, I'll just scan a folder. So this is a recent data set that we have obtained. It's a patient data set from Ames Valley that has a ventricular septal defect. So I'll directly show over this data set only how to do the segmentation, and once the particular segmentation is done, how we can export out the particular file for either 3D printing, which is explained in yesterday's session how to do the particular modeling, and later on do the export. I'll just show for a live application how we do the same. Also, uh, once it is done, I shall be also showing a live case that I had modulated before and done the 3D printing out for the same. So just let me bring the sample. Yeah, sorry for the convenience. Just I'm switching on my camera to show one such example that I had recently done the segmentation for and later on conducted the 3D printing. So I hope my camera is visible. Yeah. This is the particular sample case that we had worked on. So it's a four-part sample that we had done the segmentation and later on the 3D printing was conducted for the same. So to open the sample data set, let me click on open project. Meanwhile, let us load a 4D data set. So I'll also showcase the 4D applications in simple way. So just running it down, opening the project section. So this was the simple where project that we had done the segmentation for using auto segmentation. Also, some manual segmentation tricks were used to just refine the segmentation that we have obtained from auto segmentation. So this is the exact replica of the 3D printed model that was created. So let me show. This is one such part you can see. It's the same part that you can see in the screen right now, where we had done the segmentation for. Let me into some video settings so the data can be visualized. Yeah, I hope now the data is clear. Let me remove the blur and move on. Yeah, so over my screen, you can see my screen as well as I'm also spreading my screen, my camera. So this was the project that I had recently worked on. This particular patient also had a VHG defect and a particular modeling was conducted for the same. So you can see whenever we do the particular segmentation and followed by that to do the 3D printing, what we do, we select out and create multiple parts in a single file. So this is one such part
that we had
that we
created.
had created.
So
So
it is
it
the
is the
exact
exact
replica
replica
of
of
what we are seeing
what we are seeing in the
right
screen
now.
right now.
We have
We
modeled
have
this
modeled
part
this part
to see the
to see
internal
the
features.
internal
You
features.
can check
You can
from
check
here.
from here.
This part,
This part,
it's
it's
solidified part
solidified part
because
because
these are the
these are
connectors
the
that
connectors
are
that are
necessary when we are
necessary
doing
when we are doing
any
any
sort
sort
of
of additive
additive
manufacturing.
manufacturing. This was one
This
part,
was one part.
and what
And
we
what
generally
we
do is
generally
we
do
place
is we
some
place
magnet
some
points
magnet
over
points
the
over the
top
top
and
and
around the
around the
side
side
section.
section.
Because
Because
once
once
it
it
is
is
done,
done,
we
we
can
can
just
just
stick
stick
different
different
parts
parts
all
all
together.
together.
So
So
for
for
example,
example,
this
this
is
is
one
one
part,
part,
and
and
if
if
I
I
need
need
to
to
stick
stick
out
out
another
another
part
part
for
for
the
the
same,
same,
I
I
just
just
need
need
to
to
select
select
out
out the
particular
particular
pieces
pieces
and
and
I
I
can
can
directly
directly
connect.
connect.
And
And
how
how
we
we
can
can
visualize
visualize
the
the
same?
same?
So
So
earlier,
earlier,
uh, this
this
is
is
the
the
second
second
part
part
that
that
we
we
have
have
connected.
connected.
So
So
now
now
you
you
can
can
see
see
there
there
are
are
two
two
parts.
parts.
Still,
Still,
we
we
can
can
see
see
the
the
VST
VST
defect
defect
over
over
here.
here.
So
So
VST
VST
defect
defect
is
is
basically
basically
the
the
ventricular
ventricular
septal
septal
defect
defect
between
between
the
the
left
left
ventricle
ventricle
and
and
the
the
right
right
ventricle
ventricle
that
that
causes
causes
the issue
issue
in
in
the
the
blood
blood
pumping
pumping
from
from
one
one
chamber
chamber
to
to
another.
another.
And
And
it
it
might
might
also
also
result
result
in
in
cardiac
cardiac
arrest
arrest
after a
after a
period
period
of
of
time
time
if
if
it
it
is
is
not
not
treated.
treated.
So
So
what
what
generally
generally
is
is
done,
done,
a
a
baffle
baffle
is
is
created
created
according
according
to
to
this
this
particular
particular
dimension.
dimension.
And
And
once
once
the
the
particular
particular
baffle
baffle
is
is
created,
created,
it
it
is
is
inserted
inserted
inside
inside
the
the
patient
patient
and
and
the
the
particular
particular
surgery
surgery
is
is
performed.
performed.
So
So
this
this
is
is
one
one
such
such
live
live
case
case
study.
study.
So
So
earlier
earlier
on
on
it
it
was
was
a
a
three
three
segmented
segmented
model.
model.
Later
Later
on
on,
to
to
increase
increase
the
the
efficiency,
efficiency,
what
what
we
we
had
had
done
done
is
is
we
we
have
have
basically
basically
created
created
four
four
pouches
pouches
out
out
of
of
that.
that.
So the
The
output
output
efficiency
efficiency
could
could
be
be
increased.
increased.
Once
Once
it
it
is
is
done,
done,
we
we
just
just
place
place
it
it
like
like
this.
this.
And
And
finally,
finally,
we
we
can
can
check
check
out
out
the
the
fully
fully
destructured
destructured
model
model
over
over
here.
here.
So
So
this
this
example
example
I
I
often
often
tell
tell
because
because
what
what
we
we
are
are
learning
learning
about
about
the
the
software,
software,
but
but
we
we
don't
don't
know
know
what
what
are
are
its
its
practical
practical
applications. So
applications. So
practical
practical
applications
applications
play
play
a
a
crucial
crucial
role
role
while
while
understanding
understanding
the
the
tool.
tool.
This
This
is
is
for
for
medical
medical
applications.
applications.
So
So
if
if
anyone
anyone
is
is
planning
planning
any
any
startup
startup
along,
along,
they
they
can
can
have
have
such
such
look
look
how
how
they
they
can
can
do
do
the
the
3D
3D
printing
printing
of
of
anatomy,
anatomy,
how
how
they
they
can
can
do
do
the
the
3D
3D
printing
printing
of
of
any
any
implant
implant
to
to
be
be
designed
designed
for.
for.
Now,
Now,
coming
coming
back
back
to
to
the
the
segmentation,
segmentation,
how we
we
have
have
gone
gone
in
in
this
this
process
process
to
to
segment
segment
out
out
the
the
anatomy
anatomy
at
at
this
this
level.
level.
So
So
it's
it's
quite
quite
simple.
simple.
Just
Just
I
I
have
have
loaded
loaded
the
the
particular
particular
patient
patient
data
data
set
set
over
over
here.
here.
Let
Let
me
me
zoom
zoom
in.
in.
So
So
we
we
have
have
obtained
obtained
all
all
the
the
particular
particular
previews,
previews,
origin,
origin,
sagittal,
sagittal,
and
and
decimate.
decimate.
And
And
I
I
call
call
this
this
particular
particular
data
data
set
set
as
as
magical
magical
data
data
set.
set.
Why
Why
sir?
sir?
Because
Because
whenever
whenever
we
we
are
are
importing
importing
any
any
4D
4D
image
image
data
data
set,
set,
we
we
just
just
don't
don't
only
only
see
see
the
the
different
different
parts
parts
in
in
the
the
heart,
heart,
but
but
we
we
can
can
also
also
see
see
actual
actual
mimicking
mimicking
of
of
heart.
heart.
How
How
to
to
do
do
that?
that?
So
So
you
you
can
can
see
see
over
over
here,
here,
there is
there's
a
a
frame
frame
toolbox.
toolbox.
So
So
whenever
whenever
we
we
are
are
operating
operating
on a
on a
4D
4D
CT
3D
data
data
set,
set,
we
we
can
can
just
just
click
click
over
over
here
here
and
and
it
it
will
will
do
do
the
the
processing
processing
and
and
we
we
can
can
see
see
the
the
mimicking
mimicking
of
of
heart.
heart.
But
But
currently,
currently,
there
there
are
are
a
a
lot
lot
of
of
noises
noises
that
that
are
are
being
being
present
present
in
in
the
the
data
data
set,
set,
which
which
might
might
also
also
cause
cause
distortion
distortion
in
in
the
the
result
result
produced.
produced.
So
So
what
what
we
we
do
do
for
for
covering
covering
out
out
the
the
following
following
issues is we
we
do
do
the
the
first
first
segmentation.
segmentation.
We
We
generate
generate
a
a
volume
volume
metric
metric
pool
pool
of
of
the
the
same,
same,
that is
that
the
is the
blood
blood
pool
pool
model.
model.
And
And
once
once
the
the
blood
blood
pool
pool
model
model
is
is
generated
generated
out,
out,
all
all
the
the
unnecessary
unnecessary
parts,
parts,
the
the
orthopedics
orthopedics
and
and
all
all
are
are
removed.
removed.
Also,
Also,
we
we
have
have
alternate
alternate
way
way
to
to
do
do
out
out
the
the
same
same
where
where
we
we
can
can see out different slices, we can use various background volume rendering tools. To have a much more clarity for the following dataset, we can also uh, moderate the particular volume rendering settings over here to reduce out the noises that are being present in dataset, cover out less peaks, and I can furthermore define the surface. So, for example, this way I can reduce down the noises, and once the noises are reduced, we can have a better clarity about the imaging, and then we can again use the image frame toolbox to see the actual mimicking of art. So what is basically a mimicking? It is the particular building of art is covered into 10 cyclic stages. So just from diastolic to systolic, we have a actual representation how the heart is beating and how the dilution of the particular realistic effect is changing. To do that, we can do the same. Just we need to pause the particular part. We can enable the 3D level probing. We can carry out to the specific part. And now, if I enable this, what it will do is it has done and created a shape out of here to have a better visualization of the dataset directly in the volume rendering. But some might ask that still the dataset is not clear. How can we have a clarity? And when we are dealing with any surgical cases, That's the topmost priority to have the data as clear as possible. So what we do for such cases is we opt in a threshold-based approach where we just select out the region which is carrying out the particular hard part. So we can see over here this particular data set sits since it is a computed tomography of ratio, so it is a CTA data set, and corresponding to each time frame there is a different validation. Let me close the other window. Yeah. So whenever we will switch on the frame, it will have a different validation. So what we need to do in such cases is we need to select out the target frames as all frames. So whenever we will be doing out the segmentation, for all frames, it will do segmentation at once. So whenever we will select such part, now we need to fill the all the small cavities that are occupying the voxel count, that is volume pixel count, around 27 voxel units. And we also click on this part only keep the largest resulting height. So if there are any sort of deformities, that can be removed in a single click operation. Once that is done, you just need to click on apply. Since it is a 4D data set, so all the time frames are being considered and the segmentation takes place corresponding to all the time frames. And the data set also increases according to the particular frames that we are working with. So for example, if we are selecting just 5 frames, so it will take a slight less computation time, it will take slight less memory as compared to the whole model that is modeled around all the particular time frame. But to have a better and clear picture, we generally use this particular set of approach. Now, coming back to the same data set, if you're applying the filter, it will take around 1 to 2 minutes just to do the manual segmentation. There may be also a question that when we will do auto segmentation, how we can rely on the result quality. So we have two modes of segmentation. Either we can check out the auto segmentation in the systolic mode, and we can check the auto segmentation in diastolic mode. And once that is done, we can have a clear representation how the result is varying over the particular period of time. Or else, we can also use auto segmentation for all the time frames at once. Though when we are using auto segmentation for a 4D data set, it generally takes around 10 to 15 minutes to compute. So after this process is completed, I'll just save a SIP file and I will again open this particular data set so auto segmentation can work in background, and meanwhile I can showcase the other features. So it will take just like a few 10 to 20 seconds more to compute this data set. And whenever we are working with any image modality, the most difficult one that is considered is always the 4D data set because it is very quite complex to interpret. And for example, the right ventricle might be at one single position, but when the time frame changes, the position also changes accordingly. So we have obtained a particular threshold range of the same. First, let me save a SIP of this since the fusion screen was bulbing. So I'll see bulb one. Okay, create a folder over here, save that IP file. Meanwhile, we have done the manual segmentation. That is a blood pool model to be created. That was shown in morning session 2. How we can create a blood pool model. What are the different operational procedures like using a threshold value. Then we can also further define the model using a region growing uh, background slit fill. We can also smooth out the particular surface. But just to show how the basic operation procedure works, this is the basic SOP that we are required to follow while we are segmenting out any 4D image dataset, and it generally takes time when we are processing for the same dataset. Just give me a sec. Yeah, so it has saved the particular file. We can also see what type of thresholding it is approached, and we can see this is a good level of thresholding approach that it has created a model for. Now, what I was saying is now all the particular remaining noises are generally removed. I can also crop the region from the top because some part of data is not required. We can eliminate that part. We can also reduce the another region of interest. So the memory dataset memory size might get decreased from 210 MB to around 60 MB or 70 MB. We can just select the particular file size, select it across all frames, applying for the filter, And whenever we are working across all planes, we need to check into consideration whenever we are doing the cropping. So as said, the dataset memory size decreased to around 60-70 MB from 210 MB, which is a quite huge reduction. Now, whenever we are visualizing the result, what we can do is, before that, we can use a mask plug fill to remove out all the disconnected region. I'll apply the operation as a replace. Clicking on the mask, it has removed the disconnected region for me. Now, whenever we will be clicking on this part, we can now actually see how the particular chambers of heart are changing corresponding to each and every time frame that we are computing the result for. Once that is done, we move on to our next part, that is the visualization of defect corresponding to certain point. So the defect visualization can be directly done in the software itself. We need not and we don't require at all a 3D printed output. Just a 3D printed output is required in the cases where the surgeon needs a haptic feel of the same. And but if we are researcher and we are just focusing on the biomedical application, so we can just use a volumetric approach and the software itself completes the task for us. Once that is done, we can just stop the time frame and we can again navigate through this part. Now, to visualize the internal structure without even doing the 3D printing, so what we can do is we have a 3D clipping option in the view section. So our view section comprises with lots of features to be used. We can use various other methods like parallel projection to change the particular angular axis. We can also smooth out the particular volume rendering directly. We can set out the planes according to our specific requirements. So there are multiple settings that we can work on. Here we can see the uh, chamber separation over here, and when we'll move a slight right over here, we can see the particular VST defect being observed over this part. So once we are quite compatible with working with the dataset, we can easily visualize the defect, the corresponding point of defect, so the surgeon can plan the particular baffle accordingly. We don't have a baffle creation over this tool, but what we can do is we can design the baffle in any freeform or Blender software, and then we can do the particular placing over here. Similarly, can be done with the stand. If we have developed a stand graph, what we can do is we can select out the particular part, and then we can directly set out in the 3D view. We can set the stand graph directly. Now, this particular model is not smooth. We might require certain sets of operations to be performed. So what we do is we go over here in the image processing. First, let us smooth out the particular surface. One value I think will be the most that is required for this case. It will take some time. Once it is done, we'll just click on generate fast process, and it has smoothed out the particular surface by a bit amount. But still, there are a lot of improvements that are required for such surface to be worked on. So what we need to do in such cases is we need to first use a close tool to close out the surface by around 0.5 subvoxel count and one around voxel count. Once we have done this, it will bring all the pixels together by one voxel unit, means one pixel unit in XYZ direction. Also, the subvoxel count is 0.5. So to the half decimal place of the specific voxel, it will again try to bring the particular parts of the front image this together and stick at server. So what it is doing is just trying to interpolate different sets of images in a single click operation. Once we have done this, let us now check the auto segmentation in 4D, how the auto segmentation looks, and depending on data set to data set, how we can vary out the same. After this hard part, I will also just set out how to work on other muscular structures like arteries, how to use the arteries segmentation, how to use the particular arterial modeling to check out the CFD flow. Then I'll be also covering out the brain part. That would be the last topic that we will be covering in this section using simpleware. And in tomorrow's session, we shall be seeing the virtual reality based software, that is solutions, how we are using it for doing any sort of virtual reality segmentation, how we use the VR headset to do the same.
and that will
And
be
that
a
would
very
be a very
interesting session
interesting
to
session
join.
to join.
How
How
the
the different
different AI
AI
and
and
techniques
techniques are
are
shaping
shaping
the
the future
future
of
of the
healthcare
healthcare
industry.
industry and the biomechanics too.
So
So
let the filter
let the
apply.
filter
It will
apply.
take
It
some
will
more
take
time,
some more
around
time, around
2 to 3
two to
seconds.
three seconds.
Once the process
Once
is
the process is
completed,
completed,
it will
we'll
again
again
generate a fast
generate a
review,
fast review,
and we can see
and
it
we
has
can see it
brought
has
the
brought
particular
the
pixels
particular
together.
pixels together.
Just
It
close
has
the small
closed the
gaps
small
that were
gaps that were
present.
being present.
Still, there are
Still,
some
there are
parts
some
that we need
parts
to
that we
remove.
need to
What we
remove.
can do is
What we can do is
we can
we can
again apply for
again
a
apply
mask
for a
refill
mask refill
in all the
in
particular
all the
mask.
particular mask,
It
and
will remove
it
out
will
the
remove out the
islands that
islands that were present.
now it
Now,
is
it is
quite
quite
good model
good
to
model
generate
to
a 3D
generate a
printing.
3D printing for.
So what we
So
do
what
for
we
such
do for
cases
such
is for
cases
3D
is for
printing
3D
also we
printing
have
also
two
we have
approaches.
two approaches.
Since we want
Since
a
we want a
hollow
hollow
mask, so what we
mask,
can
so
do,
what we can do,
the first
the
approach
first
being
approach being
we just need to
we just
copy
need to
this
copy
particular
this
mask.
particular mask.
Now
Now,
for the copied
for the
mask, we
copied
can use
mask,
a
we can use
process
a
known as
process known as
dilation.
dilation.
So we can
So we
dilate
can
out the
dilate out
whole
the
mask
whole
by
mask
certain
by
voxel
certain
unit.
voxel unit.
So
So
applying for the
applying for the
standard
standard
one voxel
one
count.
voxel count.
Once the
Once
dilation
the
is done,
dilation is done,
what we'll do,
what we
we'll
will do,
use a
we will
Boolean
use a
operation
Boolean
to
operation to
subtract the
subtract the uh,
original mask from
original
the
mask from the
dilated mask that
dilated
we have
mask that
produced.
we have produced.
Once that is done,
Once
we
that is
can
done, we can
obtain a
obtain
hollow
a
structure
hollow
of the
structure of
particular
the particular
mask directly
mask
that can
directly
be
that can be
later on
later on
converted into
converted
surface
into surface
for doing the
for
3D
doing the
printing.
3D printing.
But this being
But
a
this being
singular
a
approach,
singular approach,
and
and
one might
one
require
might
a more
require a
efficient
more
one.
efficient one.
So first to
So
show
first
this
to
one,
show this one,
I'll use a
I'll
general
use a
Boolean
general Boolean
operation,
operation,
copy of the
copy
mask
of mask
into a section,
into a section,
or I
or
generally
I
prefer a
generally
Venn
prefer a
diagram
Venn
where
diagram
we can
where
easily
we can
select
easily
out the
select
part
out
that
the
we
part that
require
we
for,
require for
selecting it as a
selecting
new
it as a
mask,
new mask,
applying
applying
the
the
feature,
feature,
and we can
and we
see
can see
now the
now
mask that
the
has
mask
been
that has
produced
been
is a hollow
produced is a
mask.
hollow mask. We can see through these arteries,
And
and
whenever
whenever
we need to
we
check,
need to
we can
check, we
directly
can
go
directly
to
go again in the view section,
and now we
and
can
now
have a
we
much
can
more
have a much more
detailed
detailed
sectional view.
sectional view.
All the
All
particular
the
small
particular
islands
small
have been
islands
removed,
have been
and
removed,
now
and now
everyone can see a
everyone can
waste
see a
defect
waste defect
with a singular
with a singular
operation. Once it is
operation.
done,
Once it is done,
so this is one
so
such
this is one
approach
such
that we
approach
can
that
use
we
to
can
do
use to
printing.
do the 3D
Once the
printing.
mask is
Once the mask is
completed,
prepared, we can select it as mask one,
and then we
and
can
then we
click on
can click
model,
on model,
clicking on new
clicking on
surface
new
model.
surface model.
We set up
We
a
set up
model,
a model.
we can load
We can load
surface model,
surface
and
model,
since it
and
is
since it
required
is
for a
required
3D
for a
printing,
3D
we
printing,
can
so we
use the
will
option
use the option as
STL
STL
for
for
3D
3D
printing.
printing.
Here we will
Here we will
select
select
smart mask
smart
smoothing,
mask smoothing,
and we won't
and we
allow
won't
part
allow
change.
part
So
change. So
the
the
surface
surface
remains intact.
remains intact.
If we require
If we require
decimation, if we
decimation,
need to
if we need
do
to
the
do
scaling,
the
we need to
scaling, we
increase
need
the
to
scaling
increase
or
the
decrease
scaling
the
or
scaling.
decrease the
That
scaling.
too can be
That
done.
too can be done.
Once it is
Once it is
completed, we
completed,
move on to
we
the
move
full
on to
model
the full model
generation,
generation,
and later on
and
the
later
next
on the
step
next
will be
step will
directly
be directly
exporting the mask.
exporting the mask.
I open
I'll
the
open
particular
the
STL
particular
file that is
STL file that
produced
is
in the
produced
3D
in a
viewer,
3D
so
viewer. So
you
you
can
can
better see
better see
the
how
particular
the
model
particular model
varies
varies
once
once
the
the
particular
particular
3D
3D
printing is
printing
done.
is done.
And I
And
think every
I think
college
every
has their
college
own
has their
3D
own
printing
sets of
software.
3D printer. So
Whenever you are
whenever you are
using the
using
software,
the
you can
software, you can
3D
3D
print
print
out
out your output
to check for
to
its
check for
visibility.
its
Once it is
visibility.
done,
Once it is
we
done,
just need to click on
we
export,
just need to click on export,
and then we will
and
have
then
a
we will have a
singular
singular
structure for
structure
that.
for that.
Right now, I
Right now,
haven't
I
clipped the
haven't
surface
clipped the
into
surface
4
into four
different sectional
different
parts,
sectional parts,
but that too
but
can be
that
done
too
in the
can be done
surface
in the
tools
surface
option.
tools
We have the
option. We
option
have
of
an option of
clipping, that is
clipping, that is
partition,
partition,
that can be
that can
conducted.
be conducted.
Right now,
Right now,
let me take
let me take as
as well
well one,
opening the file in
opening the
3D
file in
viewer.
3D viewer.
So
So
that other
that
software
other
you can see
you
the
can see
result
the
change.
result changes in other software too.
I think in
I
this
think
system
in this
the
system
3D
the
viewer is
3D
not
viewer is not
installed.
installed.
So
So
let it
let
install
it
in
install in
background.
background.
Meanwhile, I'll
Meanwhile,
showcase
I'll
some other
showcase some
features
other
that are
features that are being
in
presented
software
in
range.
software range.
So I'll
So I'll
quickly install
quickly
the
install
3D
the
viewer.
3D viewer.
So it's
So it's
installing in the
installing in the
background.
background.
Meanwhile,
Meanwhile,
let us also
let's let us also see the auto segmentation feature for such complex cases.
What we do
What
is
we
we
do
select
is
the
we
hard
select the
city.
hard city.
Since
Since if we
we
require
require
all the
all the
particular
particular
parts
parts
in
in
the
the
landmark,
landmark, we
we
can
can
select
select
out
out
here.
here.
The
The
targeted frames are
targeted
all
frames
frames,
are
so
all
it will
frames, so
do
it
the
will do the
segmentation for all
segmentation for
frames at
all
once.
frames at once,
And it will
and it
take
will
certain
take
a good
a
amount
good
of time
amount of
to
time
segment
to
out such
segment
an
out
account.
such an account.
So
So
till then,
till
I'll
then,
just
I'll
show
just
for
show for the
particular file
particular file
that
that I
I prepared as said
prepared as
earlier,
said earlier,
how to
how
export
to
out
export out
the
the
different sets of
different
features
sets of
from it.
features from it.
Once it is
Once
done,
it is done, Yeah, so the software is getting downloaded by 3D viewer. So you can have an idea how the particular file looks in other software toolbrains. Now, opening the file again, we have obtained the file from here. So the 3D viewer got installed. Now just let me import the particular file. So let me go back, close this, open. I'll just select out my STL file and everyone can download the 3D viewer. And in majority of the computer systems, it is already well preset. So we can also change out the color from here. We can change the different settings. Now this is the outer structure, but since I told you that it is a hollow structure, what we can do is we can zoom in, we can go inside the module to check the structure from inside, and this way multiple flip based model can be created out in a quick instance of time. This is the best and the most easiest approach, but we also have one more approach to do the 3D printing model generation. So I think the auto segmentation is running in the background. So let me close this window for now and let the auto segmentation be completed. It will take some amount of time. Meanwhile, let me show the particular RTVL example that was shown in the morning session. So that we already have the particular example file known as bloodflow.sip. I'll just directly open the particular SIP file, that is SIP project file. Yeah, so once we have imported the particular result, our next task is to do the segmentation. Segmentation is how every participant might be remembering we use a plateau-based approach. We select out the region. Once this marking is done, we can click on the parts that are required. Before that, so for this arteries part, there is one more important feature that we can see. To see any blood flow in an or any arterial flow, what we can do is we can go in the background volume rendering setting. Here, we can select the maximum intensity projection and we can check the direct blood flow. So we not this way we can have a better idea about how the particular blood is flowing inside the arteries, what are the corresponding points, pressure points. We can have a clear visualization of the same directly in the 3D view. So this way we can have a better approach while we are doing the CFD modeling. We can see there is a blockage that is occurring over this point. So we can highlight the region, we can highlight the boundaries. So we can highlight the particular boundaries for which the particular blockage is present, and later on the segmentation can be performed. So like this we do, we click on apply, then there are a lot of noises that are being present in the dataset. So I'll suggest there's a better approach for dealing with such cases. The approach being to use go over in background filtering section. Here we can use a seed point, and in the seed point I can set a grayscale value around 50, -50 to 25. Now clicking on new mask, and whenever I'll click apply, it will use the operation, and the next operation that is required is merge. So it will solidify only the region that lies in the grayscale value. So for example, corresponding to this file, the grayscale value is 455. So whenever we are using a set point feature, we have set a negative delta value as -50. So it will take the grayscale value into consideration from 405 to upper value around 480. Since when we'll add 25 to 455, it will be 480. And once that is done, we will be having a grayscale range from 405 to 480, and whatever region lies between this particular grayscale range will get covered out, and this way we can develop a highly accurate model for soft tissues. So this is the best way whenever we are working in soft tissues to highlight the different regions, to mark up the boundaries, and we can also see how the blood then changes to flesh. So it's a very detailed model that we generally get. It's a little time consuming, but the output accuracy is quite high, and whenever we are generally dealing with high and very complex data set, so we can use this set of approach. Also, there is one more set of approach that we can use to develop this particular data set cases. that bring a profile line test approach. So what we do is we select in the threshold only, there are three sets of options: histogram, profile, and CTP set. Here we need to set out two different points. Once we set out the 2 points, we get to know the lowermost grayscale value being around 93 and the uppermost grayscale value being around 415. When we'll set the value between 93 to 415, so these points were selected and whatever is the grayscale range between these 2 points gets highlighted out. Now, coming back to this particular specific part that we were working, let me generate a fast preview, delete this part. Yeah. One more option that we get to do the particular region generation, region of interest generation, ROI generation, what we can do is we can go over in the region drawing settings. In the region drawing settings, we can replace as merged and then we can click out the parts. So you can see now the parts get full and in a instance of time, I got a proper 3D model of the arterial blood flow without any noises. So what we can do is first we can use a background scripting in that we had done a change point selection for soft tissues. We generally take a value between 30 to 10 or to 20, and once that is done, we can select out a initial mask and later on a region drawing operation can be used to finalize the particular mask. Now, if we are required to generate a CFD flow analysis for this one, what we will do is we will go over here in the smoothing filter. First, we need to smooth out the particular mask that we are working. To do that, I'll select out the value corresponding to which I need to do the smoothing for. Once this is done, we can remove all the disconnected regions that are not required for oversight of work. Yeah. Now, what we will do is, I have got this particular mask. I'll keep as the positional mask output. We need to dilate this particular point to obtain a hollow structure for the same for a CFD analysis. Once that is done, we just need to copy this particular part out using the same morphological operation as dilate, applying on this particular mask, and now we will be just subtracting the following part. So I just need this particular part, output also the same. I can delete out this region, and when I'll operate a fast preview, I can see the hollow structure. Now what are the initial gaps that are in the hollow region that is present that I can further remove, again using a mask that will approach, replacing the initial mask, and now all the particular holes and parts are getting removed, and we can directly set a particular CFD analysis for the same. So to set out the particular CFD analysis, we again have two sets of approaches. First, we can go in the measurement section. We can generate a center line for the whole network that we are producing. So whenever we are using center line based approach, it will try to generate all the particular possible curvature. For example, this is a curvature point that has five different nodes. Corresponding to different nodes, what can be the center line connecting one node to another? It carries out all the possible values that are required. Certain times, these particular values don't produce us out the efficient result. Why so? Because the surface that we are developing. So let me just delete the particular following center line and go over here in the center line tool editor. I'll just delete for now, selecting this part, deleting this particular part. Once the particular center lines are deleted, I'll show why this particular issue arose. So for example, if I just draw on this surface around this axis, I cut that part out using a 3D editing option, a simple 3D editing, a rectangular section. Now you can see there is lot of unevenness along this particular surface that we are working. And whenever we are working on an uneven surface, it might produce distorted result for us because each point will be considered as a point to generate a center line. But when we are using a smooth surface, the center will be considered to generate the center line network for the measurement. Now if I generate the particular go into measurement section, create center line, yeah. So you will see, I'll just increase the opacity from here. So all the particular sharp points that are present on the edges are considered a point for the initial center line generation. So for that, we are always advisable to have a cleaner cuts around the section, and once this particular cleaner cuts are present, we can have a easy and efficient and the most accurate CFD flow analysis. But to generate a CFD, we need to click over here, generate a create a CFD model. Clicking on setting up of model, here we need to set out the coarseness. So we can set the coarseness accordingly. Then the boundary condition is the most important part while we are setting out the particular boundary. So we can set out the particular points corresponding to which we require the pressure in low pressure inlet and pressure outlet. Then we can also set out the outflow and inflow. So all the particular parts are selected, the boundary conditions are set. We can do the particular model generation. Apart from that, we also have the additional approach of this ROI interest generation from the clipping part. So once we have done this, for example, let me show a little model that I had already generated, universal model that I had already segmented out for in the past. So it's the same model that I was showing right now. It's a segmented one. Uh, it's a cleaner one. So I invested some amount of time to generate out this model. Let us apply the same set of operation that we were discussing, morphological, then dilate this particular part, boolean. So now when I'll generate a center line, since the curvature is even along this particular surface, so you will be seeing the resulting changes. Now when I'll generate a center line, what it does is it has created an even set of points around that, and it has created short center lines for me. Now to do a CFD analysis for this surface, I'll just click on model, CFD model. Here is the setup model when we set out the boundary condition. We need to click on this add and manage clip option, and now we will select the particular from center line. So it will correspond to all the center lines. We can set out different inlet and outlet flow. For example, uh, at the bottom being the inlet and the upper one point being the outlet flow for the blood flow to be taking place. We can directly set out a fluid flow analysis, and later on the file can be exported out. We can also set the pressure points, and once the export is done, we get a detailed picture of the same, and we can run the particular file in console for the multi-physics analysis. Meanwhile, let us see. So let us see about this one, how much it is completed. It will still take some moment of time. Now, corresponding to each and every center line that is present, it has considered all the particular values for the planes to be generated, and then we can edit out the planes also. For example, if I need to set out any specific plane that I need to vary out, I can pre-position it. I can change the any dimensions that is required. I can also select and delete out my regions which are not required. So I can delete all. I can also set my own set of planes. So clicking over here, setting view, and then just directly setting out the inlet and outlet flow. We can also again add this particular region, clicking the reference points, and we can have multiple planes to be added. Once these planes are added corresponding to these planes, we can have the particular inlet and outlet to be set according to our specific requirement. Now the particular mesh refinement can be carried out, and later on the export can be selected as console file, ls dyna, MATLAB open format we take up, whichever file format is required for us. Once we are done with it, we can click on the file model solution, and later on we can export out the particular file. This being an example of arc, now we have shown an example of arteries. Two more examples are left. One is a tuber detection in an part, and the last one being the uh, cortical thickness analysis of brain using a ball thickness tool. So let me open another project file. I think this particular project file MG is the one that has the tumor. Yeah. So this one particular patient had a oncotuber over here. I had done the initial segmentation. Over here, you can't see the tumor as proper. But when I highlight the particular specification, you can have a Clear picture of the same. I'll just select out the boundary set, highlighting out different points, increasing the area over here. This is one such recent case study that I'm currently working on. Here you can see there is a tumor that is present that is basically lungs tumor that has extended all the way to ribs, and it has the patient has basically lost the control over his ribs and the parts has got disconnected. This can be better visualized over here. So it requires a special condition to be monitored for. So what I have done is I have used a uh, background freckle as 8-point operation to fill out the region. Once this is done, this is how the output looks. So it's a initial output that I recently worked on for the tumor detection on this part. This also requires other parts to be highlighted out, like whatever are the particular changes that it has occupied in the lung. So to mark out any lung part, let me show how we can do that. I'll just select a small value 10, 10, selecting out a new mask. Now I'll just select out the merge part. So to fill out the region, slightly increasing the value around 20, 30 would be fine at the negative end. Zooming in the region. You can just select out. Yeah, once it is done, we can highlight how the particular tumor has affected lung. So it was initially a lung tumor that we can see. So we can toggle any part off to see how it's varying. So it's just over here. So it has basically what this particular patient requires is this part to be removed out completely to remove out the tumor. Similarly, the tumor is extended to oncotumor, so this particular rib cage is also required to be removed. This is one such example in which the particular software is being used for any sort of tumor detection and later on removal of the same using surgical planning. So what we require is we require a surgical guide for the same. So how a surgical guide can be prepared for such model? We can take over here the surface. Once the surface is taken, we go in the 3D printing option. We can click on the create cutting guide and a specific cutting guide can be created out for the specific surface. We can click over here for the part the surgical cutting guide is required. Yeah, so it has converted into surface. Now I can go into the 3D printing operation, creating cutting guide, adding this particular guide. Since it is for two planes only, so I will just select out a shorter plane, putting this plane around here, and it will fulfill my exact requirement. Slight modification in dimension. Yeah. Once it is done, I can, if I require a pin and drill hole, I can do the same, or I can directly set out the base for the following surface. Selecting brush. Like this, a cutting guide can be easily created out, and the important junctures can easily be calculated. Once it is done, we just need to click on save and clicking on the create surface will ultimately that can create out our guide. So clicking over here, create surface. It takes me only 2 to 3 minutes to be completed. Once that is completed, we can easily create cutting guides of any shape that is required for our specific type of workflow. These are some of the important cases that might look very easy, but they're quite complex to tackle with. And once we are familiarized with the different tools that are present, like background filters or even thresholding operation, it may look easy, but sometimes When the parts are highlighted over one another, we can't even distinguish different organs from one another. So, in such cases, the role of different tools like profile line plays a crucial role, the auto segmentation plays a crucial role, wherein it will automatically generate all the possible outputs for us, and then we can work on the auto segmented part and map out the same using manual segmentation. Yeah, so this is how the cutting guide was created. We can just focus on the specific cutting guide. Doctor can help plan specific incision points over here, and the surgery could be done in the minimum invasive way. So this is one such tumor example in which the application of simple gel can be used for. Now let me open another window to show the cortical thickness example, how the particular cortical thickness plays a crucial role. So cortical thickness is basically the dimensional unit to take for any brain disease like Alzheimer's. So if he is having a loss in the particular memory, so what doctor can do is he can generate a whole thickness of the he can do the 3D scanning of the same. Once the 3D scanning is completed, he can use the software approach to highlight out the specific part corresponding to which the wall thickness is minimum, and later on it can be very efficiently used to detect of disease like Alzheimer's. To open the file, let me open the Python file inside Synopsys medical dataset. We have the cerebral cortex, so wall thickness. Since it's already a segmented region that we are having, so this is how the soft tissue part of brain looks. We can also have the same set of visualization over here. We need to change some rendering settings. For example, if I select out a bone, so it will show the outer skull region that is present since it is a part of the skull that is taken. This is the gap or the connecting tissues between the soft matter, that is the gray matter inside the brain, and the actual brain part. We just highlight the particular gray matter region, and later on in the measurement tools, we hover onto the ball thickness. Using a recasting algorithm, we can generate out the particular ball thickness for the same. We can also click over here. We can generate the statistics, expert out result, and enable this minimum and maximum enable coding. So we can check out the corresponding points that has minimum thickness. So this lies somewhere along the hypothalamus, and we can also check out the minimum thickness corresponding to which point. This particular data set was taken from a patient suffering from Alzheimer and partial memory loss. So this way, the point was uh, detected, and later on, the planning and plotting is done to how to improve the quality life of patients using such possible outcomes. These are the possibilities that one can cater to using software such as SimpleWare. Apart from that, even if we are required to do a segmentation for a kidney or any other soft tissue part, it's very easy over here, accompanied by various research-based tools. So let me open one such example, that is AII. So in this particular sample, which was again provided by INT, we were required to segment out different set of parts. So the particular patient data is the same one as so earlier that I had shown was a lung tumor, and in this particular case the tumor is a kidney tumor that is present over here. So the tumor needs to be moved out from this particular position, but to highlight that it wasn't very clear in the earlier stages. So in the earlier presets that it generally load was a triple A preset, and then we had loaded a triple A preset. Let me just load the settings over here. So this is the segmented part that we are having. So The part wasn't identified as easily. What we had done is we had used the mixed space approach. So we have done the auto segmentation for the hip region, for the particular spine region. How the auto segmentation result is we can directly test from here. This is how the output varies. We have marked a particular vertebra from we have marked a particular vertebra, cervical, then lumbar spine, then thoracic spine over here. And we have B2B3 birth marked accordingly. Then we have marked the sacrum region, followed by the auto segmentation for the hip. Then we have highlighted different soft tissues surrounding the tumor that are present. So this is still a project that I'm currently working on. It is not yet complete, but this is how the segmented output looks. We have also highlighted the liver part was highlighted, then the kidney left, kidney right, kidney cyst left and cyst right. And this was the tumor that we have further worked on. So uh, stomach is over here. The stomach region couldn't get fully highlighted out. And basically once I developed a surface for the same, it got shifted up. So the stomach and liver got shifted up as I converted out the surface for. And this was I think so the tumor that we had found out around the kidney region. Let me load. Yeah, so this was the tumor that we worked on and found out this was causing the problem in the patient. I'll just isolate this particular part, the retina first degree. This was the tumor size, and now to do the exact measurement of the tumor, we can go over here in the measurement section. We can either use a quick statistic or a normal volume measurement of the same. So over here, we checked out the volume around 389 millimeter cube. So it's a large tumor that needs to be removed to improve the patient's health. These are the following cases that we have worked. Let me show one last example of how a fully segmented heart using auto segmentation looks, because I think this process would take time, some more time, around 30 seconds. Let it complete. So this is the case how we can read and use the scheme of the simple software for any cardiovascular or soft tissue part. If anyone has any queries, the session is also open for question and answer. Meanwhile, the competition is going in the background. And I'll just request everyone to be interactive and join tomorrow's session where we shall be focusing on the VR-based segmentation solutions. That's the latest technology that's in the market, and there are very few softwares that are dealing with a fully segmented approach using the VR software. So let me show one such video that I've created. So this is the VR software. Once we go inside the virtual reality, we can navigate through the data. It was the same patient data set that I showed the 3D printed model for. So this is how the segmentation looks, how we can navigate from the data set. We can mark the region. And over here we have the added advantage that we can also do the static planning. Also, if any vessel is required, so we can mark out the area and we can design the vessel accordingly. It's a very wonderful tool to navigate. We can cut around any plane and we can work across any region that we are required. We can also do the segmentation part. So I'll just request everyone to join tomorrow's session too. Let the process be complete. So I am opening the session for question and answers. Kindly ask your specific question.
I'll also share recording of first four sessions to your TV. And tomorrow's recording will be a slight difficult. So I'll just request everyone to join the session live because paper recording will be available. So, so I'll just show you the particular polling result in tomorrow's session. I just
I
show
just saw
the
your
results
particular
in
result.
tomorrow's session. So if
So
there are
if
any
there are
queries,
any
then you
queries,
can
then
leave
we
the
can
session.
end this session.
Thanks everyone
Thanks
for
everyone
joining.
for joining.
I will
I'll
connect
look forward to
with you
connect with you tomorrow.